All right. Before we begin the class, anyone have any question? Well, the plan for today, we are going to, keep going on polar coordinates. And, this is going to be a short handout. As you can see that it only contains 13 pages, which it's going to be quick and, it's probably I'm going to use only 1.5 hours on Wednesday to complete this handout. And well, if we have time left on Wednesday, we're gonna talk about the more practice problem and the the exam, something like that. Well, but today we're gonna get you to the introduction of polar coordinates, because I guess that most of you have not seen it before. Maybe some of you, about 10% of the class, have seen it before. So we're gonna look at it again together from the beginning. And again, for those of you who wanna attend the tutoring section, so we have tutoring section today at 3 p.m. If you wanna attend, please join this Zoom, at 3 p.m. Okay, so we're gonna do some practice problem, and I'm going to answer questions that you have. Okay, so all right, let me see, 30 students now. Should I wait more? Any question, anyone? All right, so if you don't have any questions, so we're gonna go for it. So let's start by talking about polar coordinates. The idea of this week, we are trying to learn another coordinates. So why do we care? Because sometimes it's hard going to do double integral in rectangle coordinates, because the picture that you get sometimes it is not good to do the vertical line or the horizontal line. From last week, you can see that the content that we learned last week, we say that if we have a curve here and a curve here, for example, so let's suppose that you have the curve F here and you have the curve G here. When you want to find double integral with respect to this area, so the way you can do, you can draw a vertical line, something like, you're trying to do dy dx, or you can do dx dy if you want to, so it's gonna be the horizontal line. But some regions are not good to do either vertical line or horizontal line. Some region they are best treated if you do something like, some region like a circle. Let me show you here. Here. So it is not going to be okay if you do the vertical line. Well, it's okay actually, but it's just super hard, because if you do the vertical line, you have to split the region. You can see that if you do the vertical line here with this region R, it's gonna be messy a little bit, because you have the green one here, the red one here, the yellow one here, and let's suppose you have the blue one here, which is going to be a bit messy for you, because you have to start from yellow to green, yellow to green, yellow to green, yellow to green, and then at one point you have to stop and then do blue to red, 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 which is going to be tough. Or if you do the horizontal line, well, it's going to be the same thing. So one part you have to do the yellow one to the blue one, and another part you have to do the green one to the red one. Well, we're trying to avoid this issue, because we don't want to split the region. Splitting the region is not that good, because it means you have to integrate two terms, which means you're gonna have more work to do. So the idea is, why don't we do something like this? Well, that would be perfect. Something like you start from the origin here, and then you do something like that. Trying to do something like you are trying to get the radius from the circle. This way, you can see if you define the coordinate this way, you don't have to split the region, because every time you're going to start from the yellow one to the red one, and then you're going to go this way, this way, this way, this way, this, and it's going to be okay because you don't have to split the region. That is our goal for this chapter or this week. Does it make sense? We're trying to learn polar coordinate first, and at the end, we're going to use it to help us to set up double integrals. Okay. Well, today, let me first give you an idea of polar coordinate first. So this is going to be different from what you learned in high school or when you were a kid, because we're going to call it polar coordinates. So what you learn from high school, you have rectangular coordinates. That one is the one that, people are most familiar with, because rectangular coordinate, you're going to have y-axis and x-axis, and the origin is here, and you call this thing quadrant 1, you call this thing quadrant number 2, this is quadrant number 3, this is quadrant number 4, and then when you plot it for rectangular coordinate, you use the point, and then you're going to do the order pair, right? When you learn in high school, order pair, the first one is x, the second one is y. Let's talk about polar coordinates. So polar coordinate, you're going to have only the origin here, which in polar coordinate, you're going to call it pole. So pole means you're going to have, think of the origin. You're going to have just a pole, like one point here. And then the axis that you have, you're going to have only this one. Just going to the right, this one going to call polar axis. This is all you have for polar coordinates. And the way that we're going to do it, so we're going to just say that, well, every time when you plot any point on polar coordinate, the way we're going to measure it, we're going to measure it by an ordered pair as well. But what you're going to do, you're going to use the first one, the first component, it's going to be r. The second component, it's going to be theta. How do you measure it? Well, draw a line from that point to the pole. And then your r here, gonna be your radius from the pole up to that point. And then what is your theta? Your theta gonna be, okay, take a deep breath. Your theta gonna be the angle that you measure from the polar axis. You start from the polar axis, okay? And then you do the counterclockwise. So it means you have to do this way. Counterclockwise, it's like similar to trigonometry that you learned before. So, and then you measure it theta here. So this point, we're gonna say that it's r theta. Okay, all right. So I think the explanation is on page number 2 here. So let's talk about it again. So it said that the theta coordinate in r theta is this angle, okay? So, well, keep in mind that you have to start from polar axis always, and then you go counterclockwise to get theta. Well, if you do, if you have that one and you measure theta, well, we're gonna learn how to plot the point in theta. Well, you can do that one as well. Theta go clockwise direction, but the theta gonna be negative. This way it's gonna be positive. This way gonna be negative. Similar to trigonometric functions. When you learn trigonometric, some kind of unit circle, I guess. So you're gonna do something like, oh, theta go this way, it's positive. Theta go this way, it's negative. So the same thing. So that one is how to plot the point. And r is simple. I just, r actually, well, to make you more comfortable with r, you can think of radius, because r stands for radius anyway. So it's just from the pole to this point. So let's first plot the point first, because this is the first step that we're gonna learn. Okay, so let's try to do example 57 together, which we are trying to plot A, B, C, D, and E into this polar coordinate. So this one is gonna help you to plot, because I give you a picture here, but keep in mind that actually when you do the problem, you don't have to draw this thing. So you can have only a pole and a polar axis. That's all you need, because everything else is just, for the purpose of the first example, I just want you to see all the angles here, but technically you don't have that in your polar coordinates. Okay, so we're gonna have, well, let me plot this thing green, and then that one is my polar axis. Okay, well, if you are familiar with trigonometric functions, or if you are familiar with unit circle, everyone gonna know how to count the angle here. If you already forgot, you have to memorize it again. So 0 is here, pi over 2 is here, pi is here, 3 pi over 2 is here. That's pretty simple. Pi over 2 is 90 degrees, so it's something like that. And then you add more 90, it's going to be this way. This is 270 degrees. Well, if you think of the degrees, but actually we use radian, so this is going to be pi over 2, pi, and 3 pi over 2. And this is a simple one that you have. Well, basically you could have pi over 3, pi over 4, and pi over 6. This is the 3 simple angle that you learn in high school. Is 30 degree, 45 degree, and 60 degree. Okay. Well, mostly we're going to use pi over 3, pi over 4, and pi over 6. That's all. So, well, let's start by the point A here. I want to plot 1 and 3 pi over 4, which means I'm gonna, when I plot it, I have to look at the picture. Where is my 3 pi over 4 first, and then I go 1 step forward on the line 3 pi over 4. So you can see that this is 3 pi over 4. I see it here, 3 pi over 4. And from the pole here, look at the 3 pi over 4 here. You're trying to go 1 step forward, and then that's the point A. So it's gonna be this one, 3 pi over 4, and then you go 1 step forward. Okay, that makes sense. So it's like this is the 0, and then, well, if you look at on scale 1, 2, 3, so this is scale just 1, so that is A. And then the point B here. So what is the point B here? So -1 pi over 4. What would you do? So you're gonna look at pi over 4 first here, and then you go back -1, because you say that, oh, you're gonna go -1 step on the pi over 4 axis. So it's gonna be the one opposite to pi over 4 is 5 pi over 4. So this is B. Actually, it's on pi over 4 scale, the same scale, but you go back 1 unit, because B is the first component is -1. Makes sense. And number C, sorry, the letter C here. So you have 2 and pi over 6. This is pretty simple. So pi over 6, and then you go up to, this is C, because you scale it pi over 6, and then you go up 2 units. And then the last one, not the last one, D here is -1, 5 pi over 6. I'm gonna go a little bit faster. So 5 pi over 6 is here. So -1. So I go back here. So I get D. And then the last one is E. So which is 5 pi over 12. And then you go -3. So this is E. Well, hopefully you are now familiar with the polar coordinates more. So what you can observe here is that for one point in polar coordinates, you could have more than one representation for one point. Let's suppose I focus on the point A here that I highlight in light blue here. The point A is here. So I say this is 3 pi over 4, and then you go up 1 step. So what if I say, well, 3 pi over 4 is here, right? And A is here. So the one that is opposite to 3 pi over 4 is what? Is 7 pi over 4, right? You can see that 3 pi over 4, if you draw the line, it's going to be the same line with 7 pi over 4. Which means you can say A is going to be 7 pi over 4 and -1. They are the same point, right? So it's just they have more than one ways to represent it. So you can say 1, 3 pi over 4, it's going to give you A in the picture. -1, 7 pi over 4, going to give you the same picture. Moreover, you can do A1 11 pi over 4. They're going to give you the same thing as well, because 3 pi over 4 is here. You add up 2 pi, you go back. So 11 pi over 4 is back to this one again. Okay, so the same thing. So you can see that they have infinitely many ways that you can represent the point A. This is why polar coordinate is harder, because it is not like in rectangular coordinate that when you say in rectangular coordinate, you say 1, 1, it's gonna be only one way. It's gonna be just this point is 1, 1. There is no way to represent it other than 1, 1. But for polar coordinate, it's gonna be, hey, when you have A here, you have so many ways to represent it. So sometimes you need to just think of this thing too, because they have so many ways to represent it. Equation as well. So we're gonna learn today as well. So now, some of you are gonna have, well, any questions so far? Still good with polar coordinate? So give me a thumbs up if you feel like you are okay up to this point. All right, good. All right, good. So easy, right? Next one, I'm gonna look at, oh, some of you say, how do I get 11 pi? So here, well, I can say A1 3 pi over 4. If I add 2 pi, so you're gonna get the same one. So, and 3 pi over 4 add 2 pi is 11 pi over 4. So I add it in my head, so it's just a bit quick, but yeah, this is the same thing with 11 pi over 4. Well, you know, if you add 4 pi, they're gonna give you the same thing as well. So any multiple of 2 pi, so you can add it, so it's gonna come back to the same point. Okay. Well, next one is, well, you may have a question that, what about if I have A here? You can replicate the rectangular coordinates by put rectangular coordinates here. What is the point A in rectangular coordinates? Well, this is going to be useful later, because we want to learn how to switch between rectangular and polar coordinates. Because if you know how to do that, it's going to be helpful for integration. Because, you know, well, let me give you the big idea first, so you know why do you have to care this thing. So here, well, this is, well, when you do the integration, you're going to need to work with equations and point, right? Let's suppose that this one is a circle, like x squared plus y squared equal to 4, for example. So you know what equation is in rectangular coordinates, but you need to learn how to switch it to polar coordinate as well. Because at the end of the day, or you know, on Wednesday, we're gonna learn how to set up the integral, and then you have to integrate from this to this, this to this, this to this, this to this. You need to know what this is r equal to what. So you need to learn how to switch x squared plus y squared equal to 4 to equation in polar coordinate first, which means you need a relationship between x, y, r, theta. So if you know the relationship between x, y, r, and theta, everything gonna be solved. So let's start by looking at the relationship between x, y, r, and theta. So the same point, okay, the same point. In polar coordinate, you can say this is r theta. The same point in rectangular coordinate, you say this is x, y. So let's suppose they are the same point P here. So you can see that the way you do it in rectangular coordinate, you measure this thing x, you measure this thing y, and then the way you do it in polar coordinate, you measure the radius r, and then you do the triangle, you do the angle here, theta. Well, basically you already form the right triangle. Well, by Pythagorean theorem, the one that you are familiar with. So r squared gonna be x squared plus y squared. You can always use this one. R squared equal to x squared plus y squared, because this is a relationship between x, y, and r. Of course, because this is right triangle, you can do sine theta equal to y over r as well if you want, because when you remember when you learn trigonometry, so this angle sine theta gonna be the opposite over hypotenuse, so it's gonna be sine theta x y over r. So when you learn trigonometry, so you say cos theta, this is going to be adjacent, right, over the hypotenuse. So you know already that, hey, this is cosine theta, it's going to be adjacent over hypotenuse. So adjacent is x, hypotenuse is r. So which means this is x over r. In other words, it's going to be y equal to r sine theta, because you multiply r here, So it's going to be x equal to r cosine theta. So this one that I highlight in green, super important, because this is going to help you to switch between polar coordinates and rectangular coordinates. If you do understand the background from this, good. If you do not understand, memorize it. All you need, memorize it, And the last one is tan theta equal to y over x, which you can always use, because this is opposite over adjacent. This is tan theta. Okay, this is how we switch the point and equation between polar and rectangular coordinate. So let's do an example. So let's do it. So let's suppose I have x squared plus y squared equal to 4. What does it look like in polar coordinates? So here, you know that x squared plus y squared is r squared, Pythagorean theorem, the one that you have here. Here you're gonna have 4. Well, which means you have r equal to 2. Okay, makes sense. Well, if you think r equal to -2 is okay, it's okay as well. You can do 2 ways. There are more than one ways that you can represent the polar coordinates. So why is that? You can imagine that when you have a circle in rectangular coordinate, this is a circle, right? X squared plus y squared equal to 4 with radius 2. Everyone knows this because this is the basic plot for rectangular coordinates. You can see that if you do it in polar coordinate, it just r equal to 2, right? Because you're trying to do r equal to 2, which means you collect all the points that have radius 2. You don't care what angle is. So you don't see theta here. It means theta can be anything, which means you're gonna do, I don't care what theta is. I'm gonna collect all the cases that I have r equal to 2, which is good, because this is why polar coordinate is so good with circle, because the circle in polar coordinate, it just r equal to 2. Man, but in rectangular coordinate, it's x squared plus y squared equal to 4. Would you prefer to integrate y equal to square root 4 minus x squared, or would you prefer to integrate constant? Everyone gonna say, oh, if I have to integrate this thing and I have to integrate this thing, which one is easier? Of course, everyone gonna say the bottom one gonna be a lot easier because it's just constant. So, and that is our goal for this class, okay? So we're trying to switch to polar coordinates because it's gonna be a lot easier to integrate with r equal to 2. Not just because this equation looks super tough if you have to integrate, because up to get to this point, oh my God, trigonometric substitution by parts, the technique that you learn in Cal 1 gonna come back. And if you are not good at that one, there's no way that you can integrate that term. Okay. All right. So we're gonna switch it. Next one. So let's look at the line x plus y equal to 3. This looks very simple in rectangular coordinate because it's gonna be just a line. Right? This is x plus y equal to 3. Am I right? No. 1 second. X equal to 0, y equal to 3. Okay. I'm good. Yeah. So x plus y equal to 3. Okay. So let's see the equation in polar coordinates. So what is x in polar coordinate? It is r cos theta. Y is r sine theta. So it's going to be r cos theta plus r sine theta equal to 3. And if you pull out r, it's going to be r equal to cosine theta plus sine theta equal to 3. And that is r equal to 3 over cosine theta plus sine theta. This is the equation in polar coordinates. So basically you are learning that this equation and this equation, they are the same. That means when you see the line, you prefer to do rectangular coordinates, right? Because the equation looks simple. It's like x equal to 3 minus y, x plus y equal to 3, or y equal to 3 minus x. It looks simple to us. But for the line, if you're trying to switch to polar coordinate, ugly. You know, you don't want to switch line to polar coordinate. If it is not, necessary, we don't want to switch line to polar coordinate because the equation look messy. This is just x equal to y, if it is like 2x plus 5y, for example, equal to 3, for example, it's going to be more messy. So keep in mind that the thing that we're going to move to polar coordinate, circle. If you see circle, it is recommended to move to polar coordinates. But if you see the line, no, for me, no, I'm not going to move to polar coordinate unless it is necessary. Sometimes, if you have line and circle in the same picture, well, you have to pick them. But, if you have line and circle in the same picture, well, it is not that bad to see this term. So sometimes I love to do polar coordinate because you're going to get the benefit from, because you benefit from switching to polar coordinate because you have circle over there. So let's start by looking at another one here. So x squared plus y squared equal to 2x here. So this is actually a circle again in rectangular coordinates, but the center is not at the origin, right? So when you have 2x here, it's still a circle, but the origin is not going to be at 0, 0. So the center of the circle is going to move a little bit. But, well, you can see that as long as you have x squared plus y squared, it's going to look pretty simple in polar coordinate because this term is going to be r squared. And 2x here going to be 2 times r cosine theta because x is r times cosine theta. If you cancel r on both sides, so you're going to have r equal to 2 cosine theta. Very simple. So basically this one, if you, this equation, if you're trying to do it in rectangular coordinate, this is the equation of the circle, center at, I think, center at, 1, 0, which is, a little bit, move a little bit from the center. But, it looks very simple in polar coordinates. This suggests us that, well, if the circle, when you see the circle, it is good to switch to polar coordinates, okay? And the last one, y equal to -1. This is pretty simple in, in rectangular coordinate because this is just the horizontal line, y equal to -1. What if I want to switch it? So it's going to be r times cosine, r sine. R sine theta equal to -1. And that r is -1 over sine theta. And that is r equal to negative cosec theta. Well, not that bad, but not bad. Cosec is not that hard, but still, if I have to choose, I'm going to pick y equal to 1. It's easier that way. Okay, so this is how we switch the rectangular and polar coordinate. This is very important because if you cannot do this, you're going to have a hard time to switch the line back and forth. And that means you cannot set up the integral because you're going to need it to set up the integral. You know what I mean? So let's suppose like you have here, this is x squared plus y squared equal to 1. This is x squared plus y squared equal to 4, for example. If you learn how to switch already, wow, okay, Ajahn, this is I equal to 2 crap. Ajahn, this is I equal to 1 crap. So it's going to be integrate from 1 to 2 then. Wow, simple. dr. We're going to learn it later. But, well, the point here is that I want to emphasize that first of all, learn polar coordinates first, and then trying to think how you convert x and y to r and theta. The key point is like this thing. If you use this one, always work. So again, Pythagorean theorem implies x squared equal to x squared plus y squared, and x and y are here. Sometimes if you need theta, you can do tan theta equal to y over x, and then it's going to solve for theta for you. Well, there will be more example on this thing, so you're going to use it again and again for sure. All right, so I'm going to spend 20 minutes more, okay? And then we're going to stop the class. So let's talk about how to switch how to set up the double integral by using polar coordinates. So again, this thing that we learned last week, you know already that we already have two ways to do it. So dx dy or dy dx. Again, if you cannot remember from last time, dy dx mean you do the vertical line because you're gonna draw the line parallel to y-axis. So the way you cut the picture is gonna be like that. The x dy is gonna be like that. The way you cut the picture. For polar coordinates, the way you're gonna cut the picture is starting from here, the pole, draw the radius or whatever you call the ray or the radius or anything. Start from the pole always. Hit to the picture, to the region that you want. So the one that is on the bottom one, which means this one is called like the bottom curve. This one is called the top curve, because every time you draw, it's going to be something like that, right? It's like a cone here. So the one that is on the bottom curve here. The one that is on the top curve here. So again, the light blue one, I equal to b. When you set up on the integral, it's going to be here. The yellow one here, it's going to be here, like on the bottom of the inner integral. So when you set up, you always put r inside. Okay, first of all, the way you set up here, you're going to use r d theta. So you're going to use r inside and theta outside always. You cannot do d theta dr. No, not possible. You're going to do dr d theta always. So r going to be the inner function. And then r going to start from the bottom curve to the top curve. What about r here? This is the term that you have to add into it because of the chain rule. Because it is a theorem that you have to put r inside here. These actually came from the proof. So which you are a BBTECH student, you don't need to know the proof, but just memorize that you need to know when you switch the x dy to polar coordinate, the order that you're going to use is going to be r dr d theta. Always put one extra r here because it's gonna, from the proof, you need to add r in. It's like some transformation, and you use the chain rule multiple times, and then at the end, this thing gonna be the extra term in your integral. So the thing inside, no need to be worried, because if you have x, y, or anything, we can switch to r and theta, because you know already that x equal to r cosine theta, y equal to r sine theta. So the inside here, no problem. We can fix it. And the order of integration r dr d theta. What about theta? So theta gonna start from the first time that you draw the lay or radius, and then you keep doing it. And then at the end, when you stop, that one is the last one. So if you start from theta equal to alpha to theta equal to beta, so outside going to be theta to beta. Alpha to beta. And as you learned from last week, the outside one is going to be numbers always. It cannot be depends on theta and theta outside one. It's going to be alpha and beta. It's going to be just a number. So let's take a look at example. So this is all the theory, but you know, once you see example, it's gonna be more, you know, well, I hope you understand more after you see example. So let's start from example 59. So I'm gonna skip this one first. Well, this one is just, you know, the same thing, but in the book they say that what if you have different, not just the regular curve, well, gonna be the same thing because you're gonna do that as well. All right, so let's start from example 59 here. So let's suppose that you have a region R in the picture. So, and the question asks you to set up double integral here. And then let's suppose that they don't say anything. They want you to set up double integral. So you can pick the order you want. So keep in mind that the order that you can do, okay, now you can do 3 ways. So you can do the x dy if you want. You can do the y dx, or you can do r dr d theta. You have 3 ways to do it. So the first one, the first question here, I saw this picture. This is actually a circle. You know, with you know, one pizza is gone because someone took it already. So you only have 3/4 here. How about I'm gonna use the polar coordinate here, because I saw that if I wanna cut the area here, I can do this. It's gonna be a lot easier for me. Do that, do that, do that. So I get all the area here. So I don't have to do the vertical line, which I don't like it because I have to split it into 2 regions. Or I don't have to do the horizontal line because I have to split it into regions. So if I want to set up the double integral, it's going to be double integral, okay, r dr d theta. So r start from what to what. So this is the pole. And then you're going to do that every time. Well, you can see every time in the double radius, you start from the pole, hit to the circle, the pole, hit to the circle, the pole, hit to the circle, pole, hit circle, pole, hit circle, all the way, all the time. So the pole is what? This is I equal to 0. The pole means I equal to 0, right? Because it means you don't have any radius. So R equal to 0 is the pole. What is the, well, basically you are telling that the pole is the bottom curve. How about the top curve here? Okay, that is a circle with radius 4, which is x squared plus y squared equal to 16. That is the equation of the circle with radius 4. Or in other words, it is r squared equal to 16. Or in other words, it is r equal to 4. So 0 to 4. Okay, and then how about theta from where to where? So, well, I start from theta equal to 0. Keep going, and then I'm gonna end at theta equal to 3 pi over 2. So 0 to 3 pi over 2. And then f, well, usually you use fxy, right? This one, x is cosine theta, y is sine theta. Bam, here we go. That is your polar coordinates. You know, the thing that we like about polar coordinate is you can see that the upper bound and lower bound of the integral look simple and easy. Because, and then when you integrate it, you're gonna have no problem with the integration because your integral or your upper bound and lower bound is so simple. If you don't want to do that, let's suppose that someone gonna say, Ajahn, we're gonna do fxy dy dx because we like to do the vertical line. You can do that, but let's split that to number 1. And then another piece to number 2. So you start from number 1 first. So again, if you want to do this piece first, so it's gonna be, okay, this, they're gonna be your bottom curve, this gonna be your top curve. So your bottom curve gonna be y equal to negative square root 16 minus x squared. Top curve gonna be square root 16 minus x squared, because this one, the top curve, it is y equal to square root 16 minus x squared. This one, bottom curve, it's gonna be y equal to negative square root 16 minus x squared. And then your x gonna be from -4, which is, the outbound of your, the range up here, -4 to 0. And then you add from 0 to 4, and then fxy, dy, dx. And then for the second piece, you're going to start from 0 here up to this point. This is also correct. But you see how terrible it is if you use dy dx. Well, the concept looks simple because you can draw vertical line, but when you integrate it, you're going to have super hard time to do it because this square root going to mess you up. And then you're going to, at the end, you're going to, oh my God, I need to do trigonometric substitution. I have to do by part. I have to do U substitution again. So long. And also you have to do 2 pieces. Well, always circle gonna work well with polar coordinates. How about this thing, parabola? Let me see. So parabola, this one. Well, of course, can you guess which one is easier? Parabola, for parabola. Which order that you're gonna use? Gonna be the easiest for this one. Okay, then answer me in the chat. Which one you're gonna use? The last question for today. If you have to pick one, are you going to do the x dy, dy dx, or r d theta? Pick one. Natsima is the first one to answer dy dx. Perfect. Well, you're good. Well, some of you said dy dx, some of you said the x dy. But I think mostly people are going to tend to dy dx. Okay. So if you answer dy dx, I hope you understand that you answer dy dx because you see from the picture that it's easier to do the vertical line, right? Because every time if you do dy dx, it's going to be okay, crap, because y gonna start from 0, right? Because y gonna start from here. Your bottom curve, your top curve gonna be the dome here, which is y equal to 1 minus x squared. So simple to do dy dx. And then your x going to be -1 to 1. This is okay. How about if I use the polar coordinates? Well, I'm going to show you it is not that bad. d theta, right? If I use polar coordinates, so what I'm going to do is, okay, clean the picture again. So follow my laser. It's going to be this. Well, it's okay because you don't have to split the region as well. So you start from the pole again. Every time when you start from the pole, you're gonna draw a radius array, and then it hit this one, which is an equation of parabola, always. So you're gonna start from the pole, I equal to 0. And then you're gonna hit the parabola, which is the question mark that I have here. The question mark that I highlight in light blue here. So let's do the scratch work. Y equal to 1 minus x squared. So what is r here? So you're gonna replace y by r sine theta, x by r cosine theta, then square. And then you have r sine theta equal to 1 minus r squared cosine theta. What is next? Hard. And then how about what should I do then? Pretty hard. I'm gonna move this thing r square cosine square plus r sine theta equal to 1, minus 1 equal to 0. So now you have r square cosine theta plus r sine theta minus 1 equal to 0. So it's back to the equation ar square plus br plus c equal to 0. And then you can solve for r by using r equal to negative b plus or minus square root b squared minus 4ac over 2a. This is the formula for what? formula for quadratic equation. You know, you can see, right, that parabola is not a good one to do the polar coordinates because the equation are that you get terrible. Well, if I keep doing it, it's gonna be you know, negative sine theta plus or minus. Well, you use b as an r. What I mean is you're gonna use b here that I circle here, using sine theta as your b. Your a you're gonna use cosine square theta, and then your c you're gonna use -1. And then once you plug in everything over there, so you're gonna get r equal to something, which is gonna be here. The thing that I crossed the mark here, and your theta gonna be from, well, theta is not that hard. It's gonna be 0. Right? Theta equal to 0. This is theta equal to 0, and then you keep doing it until theta equal to pi. So the outside one is not hard, it's 0 to pi. So the hard thing is gonna be the question mark one that you need to do more work to get the equation. So I hope you learned today that polar coordinate is not the best way to do on all questions. So it's gonna be super good for the question with circles. If you see the line, the parabola without any circle in your picture, you don't have to switch to polar coordinate.